Okay, hi Bailey. You just walked out, and we miss you. We hope you're having fun. Tyler, do you have anything to say to her?
Hi.
He just says hi. Haley, do you have anything to say to her?
You left me with Tyler.
Whoa! Awkward moment. All right. 7.1b. Verifying. Whoop. It's an R. Oh boy. Verifying trig identities. I don't have a sheet of notes for you guys for this, sorry. And so what we want to do is a verification process happens by, kind of proving or showing. Okay, and so the first example I'd like to take you guys through is pretty easy. I think you guys will agree that it's that you like this one. Okay, so the difference is that they give you an equal sign. An identity has an equal sign attached to it. We want to show that the left side is equal to the right side. So we have the left-hand side. We have the right-hand side. Whoop. You can't work with both sides. You have to work with one. It's the rule. It's just the way it is. Which side would you like to work with? Left-hand side. So we're going to only work with the left-hand side and make it come out to be the right-hand side. Okay? What do you want to do first? Good. Let's distribute. Cosine of theta times secant of theta minus cosine squared of theta. Now what? Yeah. Okay, so secant is because cosine and secant are inverses of each other. You could have skipped that step if you would have wanted to. What happens when you take cosine times secant? You just get 1. So again, I just continue to work on the left side and write the stuff down. I get 1 minus cosine squared. Which is cosine squared. Which is equal to what I had on my right-hand side. There's all sorts of things you can write here to show that you're done. And so this is your kind of your mark as a mathematician. Yep, that's it. Yep. You can write down, first hour like this, you can write down these Latin letters. Well, they're English letters. QED, it's Latin for something I don't know how to say, but basically says that which needed to be shown has been demonstrated in our problem. So it's like the proof has been shown. Okay, it's been completed. So you write QED, say you're done. You can put a little box at the end. You can even put check in if you want. You can write done and underline it. So. It's funny. I've never had anybody ask that. And second hour, somebody said, "Are you going to give us one where it doesn't work out?" And I said, "No." And now you ask. No. And if the book does, it's because they made a mistake. But question? you have, well, first hour was, or second hour was really excited. They were like, wow, I could write QED at the end, like Latin, and people won't even know what it means. But nobody even looks at their homework anyway other than me. But they just thought it was fun. So we always look forward to that. It's like the icing on the cake. It's like, oh, I get to write this at the end, and I don't even know what it means. But it's really cool. Like when I started my class this summer, you know, the teacher would go to the board and say, well, these are symbols that you need to know now. I'm going to use that one. I'm going to use this one. I'm going to use this one. And I'm going to, you know, he'd list them all off. He'd show us what he meant so you wouldn't have to write everything. So now you can feel like you're really smart. You know mathematical jargon. All right, here's your second example. What if we got this? Is there a question out there? I hear. Oh, sorry. We should be able to use any letters from the English alphabet or from the Greek alphabet. So, sorry. Okay. Your book goes back and forth. So, would you like to work with the left-hand side or the right-hand side? Let's work with the right-hand side. I need some extra space, so this will be my work over here. Okay. What do you want to do first? Common denominators. The common denominator will be 1 minus sine of x times 1 plus sine of x, right? Okay. Okay, so Casey just demonstrated some foresight. Good job. Or maybe Hannah too. I don't know. I couldn't hear your voices appropriately. I'm sorry. Don't get so mad at me. Bailey, Hannah's now offended. She never got offended on days where I gave her credit that she didn't deserve. Now she's all upset. Okay, so everybody okay with that? So let's look at the foresight that these two fine young ladies had in the back row. They said that if you take 1 plus sine of x times 1 minus sine of x, what do you get? 1 minus sine squared, which is cosine squared, right? So just think about it. You get cosine squared in the denominator, right? That's really important. Why? Because tangent is sine over cosine, and secant is 1 over cosine. See the cosine squared in the denominator? So again, that's really good foresight if you can see that. So let's work this problem through. We kind of see where it's going. Let's multiply 1 times 1 plus sine of x is just 1 plus sine of x. Minus, over here we'll have, I guess in parentheses, 1 minus sine of x. And that's all over. In the bottom here, I've got 1 minus sine of x squared, because they're conjugates, and so the middles will cancel. You just be left with both squared. Subtraction. How do you like that? Okay. You love it. So, I've got 1 minus positive 1, which is 0. Good. And we have sine of x minus negative sine of x, which is 2 sine of x. See, we got the 2. It's right there. That's kind of nice. And in the bottom, you said that we have cosine squared. So you see, I kind of peeked ahead at the problem, and I saw, oh, I've got a sine over a cosine and a 1 over a cosine over here. Do you have that right here? You sure do. We can just separate this. 2 sine of x over cosine of x times 1 over cosine of x which is 2 tangent of x times secant of x, which is what I have on the other side. And now I can write QED. And I feel all good. Now let's put Kelly Sanderson to the test. So now if I go like this, do you know what the antiderivative tangent secant is? Just secant. So you can see that the reason why we want to do is because you're going to use it later on. And then we'll like attach a pi over 4 and a pi over 6, and we'll find area and all sorts of good stuff. It'll be great times. Okay, so that's that. Yeah, there you go. So it's good times. You guys need to practice this. This isn't easy. It's not supposed to be easy. It's not supposed to be easy. It's okay if you get frustrated. It's okay if you have some problems. What? Yeah, I'm looking through my notes here for your assignment real quick. I can't seem to find it. Oh, look, somebody wrote Yo Mama by Greta. Great. Okay, thanks, Greta. All right, so it looks like it all got moved around. So here's your assignment. We've got 7.1, page 540. Don't we just love that calculus class? 23 through 27. They're bullies, aren't they? Except for Kelly. Well, no, you kind of are a bully. I see you pick on Scherf every day during softball. Oh. Baseball. All right, 7.1, page 540, 23 through 27, 33, 34, 42, 47. There's 100 problems in this section, so we'll continue to add to this. I'm just trying to pick ones that will be good for your learning. Please stay on top of it. Don't do this. Don't go home and just say, I'm not going to do any homework because I'm taking a night off. This is important to try to work through. Good luck.